And joining us now is Chris Elvidge. He is the engineering and tech service manager for PigTek, a global company which is now managing farms in every which way you can possibly imagine, specifically here when it comes to ventilation. Chris, we appreciate you jumping in on the show for the first time. We thought it'd be really cool to do some rapid fire when it comes to the knowledge that you have. Are you ready to rock and roll with this?
Yeah, let's go.
All right. First of all, how do ventilation strategies differ in various housing systems when you got conventional barns versus the free range systems?
Well, that's an interesting conversation, really. I mean, it's the free range barns they're kind of new to the States. They started in Europe, right? So we had a lot of free range over in Europe, and a lot of that came to the United States. But the big difference you saw with the European farms were that they were a lot smaller. So your typical sow farms were 500 sows. That actually was a pretty big farm for like Germany area. And then if you go to the Eastern Bloc, the old the Russian side, that area you saw some bigger, 1,000 head sow farms. But they all had to convert then to free range. And basically what that means is, you had a barn before that had a bunch of stalls, and you had animals packed through, just all lined in the building. And there wasn't a lot of free air, at that 4 foot, 3 foot level. There wasn't a lot of free space. A lot of animals took up that space. And what happened is when we went to a free range kind of setup, or an ESF, or electronic sow feeding, or some kind of system where animals are free to move around, what you found that a lot of animals obviously found spots in barns, and they would kind of huddle together, and they would lay together, and they would end up laying. So what would happen is now all of a sudden you didn't have a lot of these crates taking up airspace. Okay. And then you had a lot of animals laying down or just free ranging around. So now you've got a lot of this air that's just like this. You got pretty much a huge tunnel barn. I mean, we say the word tunnel barn, but before, 4 feet above, it was all crates. And then it was tunnel at your head.
Oh, it makes sense.
And so that was kind of the problem we kind of ran into. And we saw a lot of this in South America, because what we do is we manufacture, we make fans and ventilation products and that kind of stuff. So, managing a barn was one thing, with the animals, but when it came to ventilation, the settings you had before really weren't working, especially in hotter climates. Because what we saw is that you started having more wind chill effect on pigs, on these sows, because your air speeds that you were running before, you had to run a higher air speed because you had a lot of obstructions in the building, or you had a lot of those heat eddies. So if you were able to look at it in a barn, a conventional barn, over top of every sow, you'd have like a little heat tornado, kind of heat rising, and all this turbulence of air trying to get through in a tunnel building. So you really had to crank that airspeed up to get the air moving in one direction. And when you had these free range buildings, now you had all this stuff spread out and pockets at areas. Now you had free lanes of air just rushing through the building. And so what we found that guys had to learn how to turn down their ventilation rates. And a lot of that would have been based off of, like at nighttime, temperature might have not changed much in the building, or in certain areas where your temperature sensors were, and humidity might have went up. And so you've kept the same airspeed, humidity's gone up. Now you're chilling these pigs, and they're all huddling together because they can free range with each other, and they're going to pile on top of each other. You're going to see, abortions and things like that. So it's kind of been a real learning experience. And I think, we're still trying to figure that out today. A lot of that goes back towards, some of the new technologies that would come up with varying fans and this variable technology, and being able to, instead of turning on one fan and having 30,000 CFM blast at once, we can slowly ramp these big fans up and slowly ramp them down. So that's just kind of the big difference between conventional barns and free range.
Well, you're clearly an expert. That's a great response. As we continue the rapid fire, Chris, what about innovative technologies or advancements in swine ventilation that producers should know about right now in 2024?
The biggest ones, I think, it goes part and part. You have these new fan technologies. So some of the newer fan technologies they're using permanent magnet type motors. And what that means is these motors actually have magnets on board now. And what that allows us to do is it allows us to truly vary the speed without, and being efficient. So if you think about you're at home, you've got this technology has been around for years. Your furnaces, you've got the high efficiency furnace where your blowers run slower, faster, depending on demand. Well, we have that technology now into the swine industry and the chicken industry as well. It's those price points for that technology finally came down to where we can afford to put them in pig barns and things like that and be cost effective. So you should be aware that those kind of technologies that we can now vary ventilation. Like I mentioned before, we're so used to staging ventilation by saying this fan comes on, this fan comes on. Now we can say this fan's on, this fan's going to ramp all the way up, and then this fan's going to turn off, or it's going to turn on another fan. The variable fan is going to turn all the way down and then start varying the ventilation. So you get a nice smooth curve. And then the other part of what you should be aware of is the control systems. I mean, good fans and all these new great products aren't any good unless you have a controller that can control them and understand that feedback loop and give the proper feedback to the fans that the room's, telling the controller to work at.
That's
so
fascinating.
those are the big ones, I think.
Can you share any insights into the energy efficient considerations, I guess, when implementing Swine ventilation?
I think some of the big ones that we've jumped on years ago when we first started, or at least one of my first projects was we worked at Iowa State, and we did a kind of a project with Brett Ramirez there. Actually, still works. He's still there at school. But one of the things that I always saw was pit ventilation. So pit ventilation has been one of these things that not everybody, you can either like it, you don't like it, you think it works, it doesn't work. Regardless, though, it's like the old saying, like, I don't know if you grew up on a farm or anywhere, if you left the light on, if you drove by the farm and the lights were still on and someone left the barn lights on, your dad or somebody was yelling at you because obviously that's burning electricity. Now the LEDs, it's not so bad, but the old incandescent light bulbs, that's 100-watt light bulb, that's almost an amp at 120, that's an amp a bulb almost. So that's a lot of money. So the idea is that those things were on all the time, and that's what your pit fans are doing. People don't realize that those pit fans are running, they're running all the time. That fan, you might only have, it might be 24 inches, but you've got 4 to 6 of them to 8 of them sometimes on your building, and they run all the time, all year round. And in the wintertime, you use them and then they'll start varying them down. And the old varying techniques actually were used they use triacs. And triacs aren't the best. What they do is they basically, in a nutshell, take the voltage away from the motor. So from, say it's 240 volts, to slow the motor down, you go lower voltage. But that voltage is turned into heat and is dissipated. So you still waste it. You're not saving any energy. Okay, so there's newer technologies like in these permanent magnet motor fans or these truly variable fans to where they actually truly do reduce. When they slow down, they do save you money. So that's the things, when you kind of look about is, that having variable fans on the big fans, that probably isn't, we try to sell those fans, of course, but that isn't where your bang for the buck is. Your bang for the buck is those fans that are running 24/7. And then 9 times out of 10, those are your most important fans, your minimum ventilation fans, and then keeping that accuracy. So
finally, Chris, I wanted to ask you what role or how does ventilation play a role, proper ventilation play a role in disease prevention?
Well, on the disease side of things, I'm no veterinarian, but what we do is we work and design. We do design air systems. We design fans to put in the buildings, positive pressure, negative pressure. And one of the things that we've really seen take off, here in the States, we've seen some positive pressure activities, but we also we do a lot in Vietnam. We have a location in Vietnam, and we've been working in the Vietnamese market now for probably 5 years now. And I've been quoting quite a few facilities over there. And one thing we've learned over there is that there's simple tactics of, before we thought filters and all this other stuff were the things to do, but there's sometimes little things like, and I'm going to share this example, is that we have companies in Vietnam that we do positive pressure ventilation with, and they don't filter the barn. And you think that's crazy, right? Like, why would you not filter it? But what they're doing is, things like African swine fever, they were coming in on flies. So a fly would land from the feed mill or somewhere, it'd come with a feed truck, or it'd come from another farm. That fly would fly into the barn, land on a pig, and then you've got ASF transmitted or flies. And so what they would do is the idea that we worked with quite a few companies over there is you turn the fans around. I mean, simply you're blowing air in the building and you have positive pressure. And the whole reason for positive pressure is you basically on your intakes, you put a screen. And so that way, if the air is always blowing out, then technically, right, you're not going to get any disease in the building. But in their case, it was just keep the flies out, because the flies were the disease and the birds as well. So it was a neat little simple thing, but on a more realistic thing, yes. I mean, ventilation plays a huge role in disease prevention. I mean, the biggest thing for disease is healthy pigs, right? I mean, healthy pigs are going to be, healthy humans, healthy pigs fight off disease just like anything else. There's so many things when it comes to disease coming into a building, but ventilation is always one of those things that if you do have a little bit of disease or you have a little bit of sickness or anything, and you have poor ventilation, you're bound to determine it's a net zero. It's bad. It just ain't gonna work.
Chris, we appreciate your time. Chris Elvidge with PigTek, and continued success to your company and all the good you're doing when it comes to the advances, when it comes to ventilation in the swine industry.
Cool. Thanks, guys. Appreciate it.